Previously, we had talked about what is trigonometry, what are its application and uses, and in this case, we are going to talk about some special angles. Special angle meaning that we are going to take some special values of theta such as 0 degree or 45 degree or 90 degree, and we'll try to calculate the values, the sine, cosine and tangent values with reference to these three special angles. Okay, so consider this diagram that we have a triangle PQR, and it is a right angle triangle at vertex R. Okay, and it is the angle theta that we will use in our reference. So in this case, based on this reference angle theta, we can say that the sine theta is equal to PR over PQ, which is opposite to hypotenuse, and cos theta will be equal to QR over PQ, and tangent theta in this case becomes PR over QR. So we are going to be using these three ratios in all calculations. All right. So let's consider a case when theta is equal to 0 degree. All right. So when this is 0 degree, what really happens? You see, the line segment PQ, when theta is not 0, makes some angle with reference to the base QR, right? But when we make this angle 0, what happens is that this point P basically falls down or superimposes on the point R, meaning the point P moves exactly on top of point R. So in that case, you can say that the line segment, the original line segment PR would be equal to 0, right? And the line segment QR will be equal to the line segment PQ, right? Because this line segment PQ has moved from its current location all the way down to the point R, correct? So once you know these two findings, when the angle is at 0, we can very easily calculate these relations. So sine theta, it is the ratio of PR to PQ, which is 0 over PQ, and it will be simply a 0, right? Cos theta will be a ratio of QR to PQ. But we say here that QR is equal to PQ. So for two values, when they are equal, the ratio is going to be simply equal to 1, right? And tangent theta, which is a ratio of PR to QR, will be a ratio of 0 to QR, and that will be equal to 0. At theta equal to 0 degree, the sine theta will be 0, cos theta will be 1, and tangent theta will be also a 0. Okay. Now let us consider the second case in which we are saying that the angle theta is equal to 90 degree, right? So when that happens, what you do is you have this point P, right? And this line segment PR is moving from its current location, and it's moving to the left up until a point that this point P becomes precisely at 90 degree angle with respect to the base QR, right? So this is your new location P, and this is your new location of the point R. What does it mean to you? Because previously the point R was here, but now it is precisely above the point Q, superimposing point Q. And that means the distance QR has become 0, right? And the line segment PR has become equal to line segment PQ, right? Now, with respect to these two findings, you can easily calculate these three relations, that sine theta will be equal to PR over PQ, but we are saying that PR is equal to PQ, hence this will be equal to 1. And cos theta, since it's the ratio of QR to PQ, it will be basically 0 over PQ, right? And whenever that happens, you can say that it is 0. And tangent theta, it is PR over QR, which means it is PR over QR, but QR is 0. So we'll say that this is undefined. So you can simply transfer these values here. The sine theta will be 1, cos theta will be 0, and tan theta will be undefined. So this is basically in principle how you calculate the values when theta is 0 or theta is 90. Now let us take a look at our third case when the value theta becomes equal to 45 degree. So in the third case, when we are talking about this triangle PQR, and we are saying that the angle made at vertex Q, which is theta, is equal to 45 degree. And we already knew that the angle at vertex R is a right angle, correct? In that case, what will be the remaining third angle of this triangle? It will be 45 degree, because sum of these three has to be equal to 180, right? So what do you know about a triangle when two of its angles are equal? The simple deduction is that the line segments opposite to those angles will also be equal. That means the side PR is equal to side QR, right? Let's say that the dimension of that side is x, okay? All we are required to calculate in this case, what will be the line segment PQ or the hypotenuse, right? But using the Pythagorean principles, we can say that hypotenuse is equal to the sum of the squares of the base and the perpendicular, right? And this is x square plus x square, or it is equal to 2x square, right? When you take the square root on both sides, you will find that h is equal to square root of 2 times x, right? Now you have all the three relative measurements of three sides of a triangle to calculate your required cosine or sine or tan values, right? Let's calculate that. So sine theta in this case becomes PR over PQ. PR is x, PQ is square root of 2 times x, or it is 1 over square root of 2, right? Likewise, cos theta will be x over square root of 2 times x, and that will be 1 over square root of 2 as well. And the tan theta is a ratio of the opposite to the base, which is x over x, and that is 1. So at 45-degree angle, the sine value is 1 over square root 2, cos value is 1 over square root 2, and tan theta is 1. So in principle, our objective was to identify these three values, the sine, cosine, and tan values, for these special cases of the angles, the 0, the 45, and 90 degree. Likewise, we could calculate some other special angles such as 30 degree or 60 degree. So with that, we will take a pause here, and in our next tutorial, we will learn a little bit more about trigonometry and its uses and its special cases.